So today we're looking at factoring day 2. There's going to be 3 other types of factorings that we've been encountered or that are new. All right. So the first one we're going to start off with is called factoring with the greatest common factor. So this could have multiple parts to it. All right. The first part is that you're most likely going to be able to take out something that has a greatest common factor in your problem. Okay. The second part might be that you can still factor what was left over. Okay. So let's see how this works. In question number 1, we have 8x squared minus 10x. Well, 8 and 10 both share a 2, and x squared and x both share an x. Okay, so what we're going to do is figure out what's left over. So we're going to have 4x minus 5 left over. And that's all you can do. All right, there's nothing else to factor that's left over in the parentheses. So the greatest common factor was the only factorization you could do for number 1. Looking at number 2. Number 2 looks like you can take a greatest common factor out and then factor something again. So let's see how that works. All right, so we have 5, 10, and 85. It looks like we can take out a 5 out of everything. If we do that, we have 5. And then left over, we have x squared. Negative 10 divided by 5 is negative 2x. And negative 85 divided by 5 is negative 17. So now you want to check and see, can you factor what's still in the parentheses, the x squared minus 2x minus 17? And the answer in this case is actually no. All right, 17 only has 2 factors. It has 1 and 17 because it's a prime number. And 1 and 17, when you combine them some way, either add or subtract, you're never going to get negative 2. So this is as far as you can go with this particular problem. And we're done. Number 3. All right, so if you're looking for common things to take out, we have 3, 3, and 6. They all have a 3 in them. And we have x to the third, x squared, and x. The most x's you can take out of all of them at the same time is just 1. Okay, we're limited by the x at the end on the 6. All right, if you take out 3x out of each piece of this expression, we're left with x squared plus x minus 2. All right, now we're going to see, can you factor what's inside the parentheses again? And in this case, unlike number 2, you can. All right, but before you do that, you want to rewrite the 3x part down as you're doing the other factorization. Okay, so this looks like a basic factorization, so we're going to put our 5 steps to factoring. We're going to put the x's first. We're going to drop the first sign, which is a plus. What times a positive gives you a negative number? That would be a negative number. And the factors of 2 are 2 times 1. Since the 2 signs are different, we are subtracting, which will give us 1 in the middle, so that's good. So this works. And then you're putting the biggest number first. So the 2 goes there, the 1 goes there. And we are done. So you're able to take the greatest common factor out, and then, because you've done that, it makes it easier to factor the remaining quadratic expression. All right. Number 4. We can take out 10. So we're going to take out 10 out of each one of these terms. We have x squared left over minus 5x minus 6. Okay. Now again, we want to see what can we take out, can we factor this quadratic expression that's inside the parentheses? And the answer again is yes. So we're going to replace the 10, because that's part of the problem. We're going to do our basic factoring again. So we have x and x. If we drop the first sign, which is a negative, what times a negative gives you a negative? That is a positive number. Then we look at the factors of 6. So this is actually a tricky one, because a lot of people will get this wrong. 6 times 1 is one of the factors, but so is 2 times 3. Okay, now because the 2 signs are different in our parentheses, we have to subtract our factors. Well, 2 minus 3, or 3 minus 2, is not going to give you negative 5, but 6 and 1 will. So the biggest number goes first, and this is our factorization. Okay? So that is greatest common factor. So notice there could be multiple things with the greatest common factor. That might be the first thing to set off the next step of basic factoring. You might even have a situation where you can do advanced factoring using grouping or bottoms-up method after you do the greatest common factor. Okay? The next type of quadratic expression that we're going to factor is called the difference of 2 squares. You may remember from yesterday we looked at an example of this. I really meant to do that today though, so let's get into this. So difference of 2 squares is called that because there are two terms in these problems, and they are both perfect squares. Okay, so x squared is a perfect square because it's x being squared. And 81 is a perfect square because 9 times 9 is 81. So a perfect square, as far as a number goes, is a number that's been multiplied by itself. So 9 times 9 gives you 81. 81 is then a perfect square. All right. Now you'll notice that in some of these problems that we factored up at top, when we did quadratics, you had 3 terms. And that's all the problems we did yesterday as well. But these only have 2. Okay. And the reason they only have 2 is because when you do them, the signs in the middle are different. Okay. And what happens is when you add 9x and negative 9x, it gives you 0 x's, which doesn't exist, so you don't put it down. So that middle term is missing in difference of two squares problems. Okay, and so you have x plus 9 and x minus 9, and that is it. All right, let's look at number 6. All right, so there's still 2 terms. There's 25x squared, that's the first term, and 49 is the second. So although there's a number in front of the x squared term, it's still a perfect square. 25 is 5 times 5. So when we do this, we have 5x and 5x. And 49 is the perfect square of 7. If you square 7, you get 49. We put a plus or minus, plus and minus in between the 5x and the 7's. And we're done. All right, keeping going. So again, you got 4x squared and negative 9. These are both perfect squares. So 4 is a perfect square for 2. And then we have x. 9 has got 3. We'll put a plus or minus between the two of them. All right, and lastly, we have number 8. So we already saw 9 is a perfect square for 3, so we have 3x. And then 1 is kind of tricky because, well, 1 times 1 is 1. So you can just put down 1 as the number. So we got 3x plus 1 and 3x minus 1. All right, and that's difference of two squares. Difference of two squares problem, as long as you recognize them for what they are, they're actually generally pretty simple. All right, now the last one, we have factor by grouping. Factor by grouping, although you have larger exponents in this, so you notice that each one of these problems has x to the third, is actually almost easier than some of the other problems we've done, like advanced factor by grouping, because this is already set up with the 4 terms. We don't have to multiply the first and last term and then find the factors of that and then make the problem. This is already set up with the 4 terms, so we can start grouping right away. So we group the first 2 terms and the last 2 terms. All right, then, just like factor by grouping with advanced factoring, we find the greatest common factor, which we've already done in questions 1 through 4. So we have x to the third and 3x squared. We can take an x squared out of both those terms. We're left with x plus 3. In the second set of parentheses, we have negative x and minus 3. We can take out a negative 1. So we have x plus 3. So just like advanced factor by grouping, these 2 sets of parentheses should be the same. If they're not, you've done something different. So you've done something wrong. We can then take the terms out in front, so x squared minus 1 and x plus 3. Now the tricky part about some of these is that sometimes because you have an x squared in your first set of parentheses, those actually might be factorable. Okay, in this case it is. This is x squared minus 1. This is a difference of two squares problem. X squared is a perfect square and so is 1. And since it's minus, that means it's a difference. So what we can do is we can do a factoring that as well. So we have x plus 1, x minus 1, and we still have the x plus 3. Yep, that's not a 3. That's a 3. So this is its complete factorization. Number 10. In this case, we can we can group the first 2 and the last 2. We have x squared we can take out, so we have x minus 4. And the second set of parentheses, We have to take out a negative so that the signs are right. And we can take out a negative 9. So we're left with x minus 4 again. So 36 divided by negative 9 is negative 4. Again, now these two sets of parentheses are the same, so that's good. We have x squared minus 9 from the parts on the outside of the parentheses, and x minus 4 from the parts on the inside. Again, if we look at our x squared minus 9, we should notice that is, again, a difference of 2 squares. Now, this won't always happen, but it is happening now. Okay, so we have x plus 3, x minus 3, because those are the perfect squares that are the numbers that make the perfect squares of x squared and 9. We still have the x minus 4 at the end. All right. So here, we're grouping the first two and the last two sets of numbers. We can take out an x squared, leaves you with x plus 2. On the second set, 4 and 8 both share a 4, so we can take that out. Left with x plus 2. All right, so we have x squared plus 4 as our first set of factors, and then x plus 2 is the second one. Now you might think, oh, we have a difference of 2 squares again problem, but that's not the case in this problem. So you have x squared plus 4. What's not a difference? This is not factorable. So this is actually the only answer you have. Okay, there's nothing else to do with this problem. X squared plus 4 can't be factored using the difference of 2 squares, so there's nothing to do with it. Okay? So like I said, it will happen sometimes, but it won't always happen. All right, finally number 12. So we group the first two and the last two terms together. Out of the first two, we can take out an x squared. We're left with 7x plus 6. The last two sets of numbers, we can take out a negative 4. Left with 7x plus 6. Again, those two terms are the same, so that's good. That's why we had to take out a negative 4, not just a positive 4. We have x squared minus 4 and 7x plus 6. Now again, looking at the x squared minus 4, that is the difference of 2 squares, so we can have x plus 2, x minus 2, and then still to have the 7x plus 6. And that is the factorization for number 12. And that is it. Okay, those are the different types of factorings that we're going to have for this unit. That is all the factorings we're going to have, so you're going to be responsible for understanding and identifying each different type and then being able to do them. All right? So please make sure you try the practice, and we'll go over any questions you have on Monday. Good luck.